Alright, today you got attributes of functions. Okay, a blank is the point which a line crosses the x-axis. We learned this in Algebra 1. This is the x-intercept, the graph. Likewise, a point at which the line crosses the y-axis is called the y-intercept. And one thing to note about x and y intercepts, if we sketch out like a picture or something like that, maybe kind of like a graph, kind of like this right here. X-intercepts over here on the x-axis, typically those will have a number and then the y value will always be 0. So you'll have like some type of x and then comma 0, and then for the y-intercepts on the y-axis, that's going to be 0 for the x part and then some type of number for the y value. So I would recommend drawing that picture as well. Kind of like a visual thing there. Alright, got a couple of new things here. You might have seen this in Algebra 1, not sure. But you have the blank value of a function on an interval is the blank y value for the x values on that interval. So you have two new things here. You got maximum and minimum. Maximum. Oh, whoops, I want to make sure we'll curl. Maximum value of a function on a given interval is the greatest y value for the value of x values in that interval. And that extra stuff here at the end is kind of confusing, but it's just the highest y value. Okay, and then you also have a minimum. Usually we'll just abbreviate that as min. So the minimum value of a function on an interval is the, lowest y value for the x values in that given interval. And I think that comes up here in a few problems here. Alright, so the first example here, graphing and analyzing a function. Graph the function fx equals x minus 3. Then find the domain and range and the x and y intercepts of the function. For the x-intercepts, plug in 0 for y and solve. For the y-intercepts, plug in 0 for x and solve. And then write down the domain and range in both set and interval notation. So if you go back to Algebra 1 here, we can kind of treat this fx here kind of like y, and then y equals x minus 3. You guys learned about y equals mx plus b. I think you even saw that in 8th grade a little bit. So the y-intercept is negative 3, start there at negative 3, and then the slope is 1, which is kind of like 1 over 1, and that'll get you your slope. So we'll start down here at negative 3, and then you'll go up 1 over 1, up 1 over 1. And actually from the graph, if you know how to graph it, you can probably find the x and y-intercepts pretty easy. It's pretty clear to see that you got 3 for the x-intercept and negative 3 for the y-intercept. But we're also going to solve by plugging in, because sometimes we're not going to have a graph in front of us, and we might not be able to see that here. So for x-intercepts, plug in 0 for y. So let's do that here. We'll even color code it here. X-intercepts, plug in 0 for y. So we're going to go 0 equals, and then I guess just x minus 3. And then you're going to solve for x. You get x by itself. So that's x right there equals 3. And then we're going to write it as an ordered pair. That's 3 comma 0. Which notice here, if we go back to our picture, we see that 3 comma 0 right there. Okay, and that's your x-intercept. Alright, for y-intercept, you notice here it says plug in 0 for x. Alright, so we're going to go y equals 0 minus 3. And then y is already by itself. We just need to simplify that right-hand side. So it's negative 3. So y equals negative 3. So we'll put this as 0 comma negative 3 right there. And then go and look. Oh, yep, there's 0 comma negative 3. That's your y-intercept. And that's it there. And then, oh yeah, domain and range in both set and interval notation. So interval notation, we use this a little bit more in our class. We're just going to say the graph goes left and right forever for domain. So we're going to say from negative infinity to positive infinity, and we put parentheses around it because you can't really put a bound on it. And then range, same thing, it's going up and down for range right there. So range is from negative infinity to positive infinity. Now as far as set notation, you got to do kind of all this stuff here. Set notation for domain, it's x values, such that x, and then this is a weird symbol here, it's one of the Greek letters, is an element of the real numbers right there. And we don't use this as much. I think it's kind of good to know how to do, but I believe most of the times on quizzes and tests we'll ask you to do it in interval notation there. For range, it's pretty much the same thing except you use y instead. You're going to say y is an element, that weird looking e thing, of all real numbers, which is an r with a little line through it. And if you want to label this for your notes, this is set notation, and this is interval. I'm just going to abbreviate that. Okay. So now we're going to switch gears to talk about max and min values of, I guess, that same function here over this interval from -7 to -1 here. So using that same function, I'll rewrite it down here so you guys have it. Y equals x minus 3 or fx equals x minus 3, doesn't really matter. And all you got to do for max and min values, especially if it's a straight line, all you need to do is take these values right here. That's an interval right there. So these are your x values right here, and that's an x, and then this is like the other x there on that domain value. And you're just going to plug them in. Okay, so if we plug in -7, that's going to be y equals -7 and then -3, which gets us -10. Okay, and let me make that look a little bit better here. So y equals -10, and then we need to go do the same thing with -1. We're going to plug in -1 into this x value over here. I can draw the arrow, right? So y equals -1 minus 3, so that'd be y equals -4 right there. Now as far as which one is the max and which one's the min, really all you got to look at is which one's higher and which one's lower. So since that first one right there, that was -10 right there, and the other one was -4, we're going to say the -10 is our lowest value. So we're going to say the min value is y equals -10, and then the max value is going to be y equals -4. That's all you need to do there on that. Now I added this extra section here, domain and range, when they give you intervals like this, because sometimes they might ask you that, so I wanted to add this in here. So if you want to add this at the bottom of your page, it's not very hard. If they give you an interval, that's usually they're telling you the x values here, which also is your domain right there. So our domain on this here, we're going to say it goes from -7 to -1. It's the same exact thing as that given interval right there. Okay, now as far as the range values goes, and remember our graph kind of looks like a line going up, kind of like that right there. Our range between -7 and -1 were these two different y values that we got. So the range value goes from -10 and then all the way to -4. So basically it uses the given interval and then it uses your max and min values. So just make sure you are comfortable with that. And that's in interval notation. We put brackets on those because we include those numbers right there. Alright, I think that is all on that one there. Without sketching the graph of the function, find the maximum value of y equals -4x plus 5 over the interval. And notice here, this is more, it's kind of similar to set notation right here. This is the same thing. If we want to rewrite it like this, we could just say from -2 to 8. And then we're going to just go take those x values. Remember, these are x values right here. We're going to plug those into our function. So you have -4 and then times -2 plus 5, and be careful with your double negatives. That'll be positive, I guess 8 plus 5, so I guess 13. And then the next one here, I guess switch colors just for kicks here. So we got -4 times 8 and then plus 5. I think that's -32 plus 5. So I guess that'll be, what's that, -27 I'm in summer mode here. I have to think a little bit. All right, and then as far as the max and min's values, we can say the max is the highest of the two numbers. That's 13 in this case. So y equals 13. And then the min was, y equals negative 27. And there's not like a rule as far as like, oh, the lowest x value is always the min and the highest x value is always max. Sometimes they can kind of be switched around there, so just be careful with that. Okay, what does it say? You're thinking about the method used to find the max and min value. Would you need to consider any other point when finding the max and min values of an absolute value graph? So I guess we really haven't talked about absolute value graphs yet, but here's what it looks like. It looks like a V, kind of like that right there. So if I say, like, what's the max and min between, I don't know, the interval 0 to like 10 or something like that. So if we just plug in 0 through 10, we're going to get like a value way up here and then a value way over there. Which wouldn't get us the min value. So sometimes we need to know the graphs to be able to, we need to know like what shape the graphs are to be able to find the max mins. The reason these came out the way they did was both of these were in y equals mx plus b form right there, which means it's a straight line. So y equals negative 4x plus 5, that's a straight line. Y equals x minus 3, that was a straight line as well. So I don't think we throw too many absolute value graphs and quadratic graphs at you right away, so I wouldn't worry too much about that. But actually, now that I say that, we have a quadratic right here, but we'll be able to kind of talk about what's going on here. So they start us out real easy. This is just y equals x squared. And if you don't remember what that looks like, you could use a graphing calculator, but I'm going to make a table here. We'll say here's your x and y values. Let's go from negative 2, negative 1, 0, 1, and 2. All right, and all we got to do is just plug those numbers in and square them, I guess. So negative 2 squared is negative 2 times negative 2. That'd be positive 4. Negative 1 squared would be positive 1. 0 squared, that's easy, it's 0. 1 squared is back to positive 1. And then 2 squared is 4. And then we can go and graph that. Kind of goes up, so it's got a little bit of a curve. I know it kind of made it like a V, but it's supposed to be curved as best you can there. Alright, so we graphed the function, that was good. Determine the domain and range. Okay, so since the graph is going left and right forever, we're going to say that the domain is still all real numbers, or we can even put, here we can say just from negative infinity to positive infinity. Now the range is where you got to be a little bit careful because it goes up forever, but then it comes down to this absolute lowest point right here. So that lowest y value is actually at 0. So we're going to say it goes from 0 and then it goes up forever. So we say to positive infinity for the range there. And actually for this 0 we're going to put a bracket there because that actually should include that point right there. Alright, and then what do we got here? What are the x and y intercepts of example 3 on the graph? So it actually, this is kind of a weird case here, it actually crosses your x and y axis at the same exact point. So your x and your y intercept are both the same thing. It's over here at 0, 0. So we'll go ahead and put that. X and y intercepts are 0, 0 for x. And then y-intercept happens to be the same thing. That won't happen every time, but it does in this case here. And then what are the max and min values on the interval from negative 3 to 4? Okay, so this is where you got to be real careful. And this is, I'm going to draw on the graph here to kind of help myself out. But they're saying like what's going on here from negative 3 to positive 4. And obviously we can't see the graph well enough, but we can see where it is the lowest. Like the max could be over here on this side, over there at negative 3, or maybe even way up here at 4. I think the max will probably be at 4 just based off of the way the graph looks. But the minimum we can see that based off the graph. So the minimum, we have to use the graph, kind of like what I was talking about with the absolute value graph right here. We have to use the graph to tell what the minimum is. So the minimum, I'll go ahead and put that just based off of the graph. The minimum is y equals 0. Now, as far as the max goes, we need to figure out which of these numbers is going to get us the biggest y value when we plug it in. Remember, we're plugging back into y equals x squared. So some of y'all might be able to do that without plugging in both and like actually working it out here, but I'm going to go ahead and write it out here. It's negative 3 squared. We plug it in, so that should be positive 9. And then if we plug in the 4, that'll be 4 squared, which that comes out to 16. So 16 is the highest of the two, so we'll say the absolute max value over this interval right here is y equals 16. And then if you wanted to go back and get your domain and range based off of the interval, you can do kind of like what we did on this problem right here. Use your max and min values to get your domain and range. Okay, last thing here we got here is we're going to be talking about symmetry. So a function has symmetry. I think that's 2 m's there. If a reflection or rotation carries its graph onto itself, and that's kind of a weird way to write it out there, but there are 2 types of symmetry that you're going to see. You're going to see line symmetry and rotational symmetry. So maybe I'll add that over here. Rotational or line symmetry. Line symmetry, pretty straightforward. It's the graph, if you reflect it across the line, is it the same exact thing? It's basically kind of like a mirror. Probably shouldn't use blue there, but if we reflect across this line right here, it should be the same exact graph. So that one has line symmetry. I guess that was example A. Example B here, there's that absolute value function right there. So this should be the same thing on both sides. B, you could say B has both rotational symmetry. Like if you rotate it, it's going to be the same thing. It's got actually 2 different lines of symmetry. You probably did a little bit of this in geometry actually. So there are 2 lines. I guess I need to be writing this down. 2 lines. This has got 1 line. Let me make sure I'm not forgetting anything else right here. What are the instructions are? The following pictures and graphs functions, do they have any type of symmetry? Okay, yeah, so been doing that. 1 line. Going back to functions or not, we can use that thing called the vertical line test. I think that was in the last video here. So you have a vertical line right there that crosses 2 times, so this one's not a function. Absolute value graph right here, there's no vertical line, so this one is a function. Okay, you got a circle here. You could draw multiple vertical lines here, and you cross twice, so this is not a function. I think there's one more here. Okay, yeah, this is kind of a weird graph. I don't know if y'all seen this here. This is a square root graph. And it's kind of like a parabola, except it's only half of it and it's on its side here. But this one here, there's not really anywhere where you can draw a line where it's the same exact thing on both sides, so this is no symmetry. But it is a function. So we're good there on that. And that is it here for today.